The interpretation and enforcement of code requirements can vary among different jurisdictions and authority-having jurisdictions, OJs. Addressing the specific question of whether panels or subpanels can be installed in laundry rooms, particularly concerning NEC Section 240.24d, which references areas not in the vicinity of easily ignitable material such as clothes closets, it is crucial to consider several arguments for and against such installations. Arguments for allowing a panel or subpanel in a laundry room include the following. Firstly, NEC 240.24d specifically references clothes closets as places where electrical panels should not be installed. A laundry room is not typically considered a clothes closet, as it is not primarily used for storing clothing. The key difference lies in the room's function and contents. Secondly, the intent of 240.24d is to prevent the installation of electrical panels near easily ignitable materials that could create a fire hazard. Laundry rooms typically do not have a high concentration of easily ignitable materials, especially when compared to areas like kitchens or garages where flammable liquids or cooking materials might be present. The concern is the proximity of potential fire hazards to electrical sources. Thirdly, laundry rooms often have adequate ventilation, which helps to dissipate any potential heat or sparks that could arise from electrical equipment. Good ventilation reduces the risk of overheating and potential fire ignition. Arguments against allowing a panel or subpanel in a laundry room revolve primarily around authority having jurisdiction, interpretation, and potential environmental factors. The authority having jurisdiction may have concerns about the presence of flammable materials in laundry rooms, such as clothing, detergents, and solvents. They may interpret 240.24d to include laundry rooms under the category of easily ignitable material, erring on the side of caution to prevent any fire hazards. Laundry rooms can be exposed to moisture and humidity due to the use of washing machines and dryers. This could potentially create a corrosive environment that could damage electrical equipment over time. Moisture can lead to corrosion and electrical failures, increasing the risk of shorts or fires. Accessibility for maintenance is another consideration. While not specifically addressed in NEC 240.24, it is important to consider the accessibility of the electrical panel for maintenance and servicing. Laundry rooms may not be the most convenient location for this purpose, especially if they are frequently cluttered or used for storage. Difficult access can delay necessary repairs and increase safety risks. To resolve such discrepancies and ensure compliance, several recommendations can be followed. Firstly, consult with the authority having jurisdiction. It is recommended to have a discussion with the authority having jurisdiction to understand their specific concerns and the basis for their interpretation of the code. This direct communication can clarify the rationale behind their decision. Secondly, provide documentation. If the authority having jurisdiction is concerned about specific flammable materials in the laundry room, provide documentation or evidence to demonstrate that these materials are not a significant fire hazard. This might include safety data sheets for detergents or evidence of proper storage. Thirdly, consider alternative locations. If the authority having jurisdiction is not willing to allow an electrical panel in the laundry room, explore alternative locations that meet the requirements of NEC 240.24 and provide easy access for maintenance. Finding a suitable alternative ensures compliance and safety. When considering the installation of electrical panels, several factors must be carefully evaluated to ensure safety and compliance with the National Electrical Code, or NEC. These considerations encompass the environment in which the panel is installed, potential hazards, accessibility, and adherence to specific code requirements. The environment surrounding an electrical panel significantly impacts its safe operation and longevity. Factors such as moisture, temperature, and the presence of corrosive substances can all pose risks to the panel's integrity. In damp or humid environments, such as laundry rooms or bathrooms, moisture can condense on electrical components, leading to corrosion and potential short circuits. Similarly, extreme temperatures can degrade insulation and other materials, reducing the panel's ability to safely contain electrical current. The presence of corrosive substances such as cleaning chemicals or industrial solvents can accelerate the deterioration of metal components, increasing the risk of failure. The potential for physical damage is another critical consideration. Electrical panels should be located in areas where they are protected from impact, vibration, and other forms of physical stress. In industrial settings, forklifts or other heavy machinery can pose a significant threat to panels located in high-traffic areas. Similarly, in residential environments, panels should be protected from accidental contact or damage from household activities. Adequate clearance around electrical panels is essential for both safety and maintenance. The NEC specifies minimum clearance requirements to ensure that electricians and other qualified personnel have sufficient space to work safely when inspecting, testing, or repairing the panel. These clearances typically include a minimum depth in front of the panel, as well as minimum widths on either side. Obstructions such as stored materials, equipment, or building structures can impede access to the panel and create hazardous working conditions. Proper grounding is a fundamental safety requirement for all electrical panels. Grounding provides a low-resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. This helps to prevent electrical shock and reduce the risk of fire. The NEC specifies detailed requirements for grounding electrodes, grounding conductors, and bonding connections to ensure that the grounding system is effective. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices are carefully sized to match the ampacity of the circuit conductors and the load they serve. When an overcurrent condition occurs, the protection device automatically interrupts the flow of current, preventing damage to equipment and reducing the risk of fire. The NEC provides specific requirements for the selection, installation, and coordination of overcurrent protection devices. Proper labeling and identification are essential for the safe operation and maintenance of electrical panels. Each circuit breaker or fuse should be clearly labeled to indicate the load it serves, such as lighting, appliances, or equipment. This helps to prevent confusion and reduces the risk of accidentally de-energizing the wrong circuit. Additionally, the panel should be labeled with its voltage, amperage rating, and other pertinent information. Compliance with the NEC is not only a legal requirement, but also a critical factor in ensuring the safety of electrical installations. The NEC is a comprehensive set of standards developed by the National Fire Protection Association, or NFPA, to protect people and property from electrical hazards. Local building codes and regulations often incorporate the NEC by reference, making it a mandatory requirement for all electrical work. Regular inspections and maintenance are essential for maintaining the safety and reliability of electrical panels. Inspection should be performed by qualified electricians to identify any potential problems, such as loose connections, damaged components, or signs of overheating. Maintenance tasks may include tightening connections, cleaning components, and testing overcurrent protection devices. Addressing these factors thoroughly ensures that electrical panels are installed and maintained in a manner that promotes safety, reliability, and compliance with applicable codes and standards. Firstly, NEC Section 110.3b mandates that listed or labeled equipment must be installed and used in accordance with any instructions included in the listing or labeling. This means following manufacturer specifications for installation, environmental conditions, and intended use. Failure to adhere to these instructions can void the equipment's warranty and potentially create safety hazards. Secondly, NEC Section 110.12 requires that electrical equipment be installed in a neat and workmanlike manner. This means that wiring should be properly supported, secured, and routed, and that all connections should be made with appropriate hardware and tools. The goal is to create an installation that is not only safe, but also visually appealing and easy to maintain. Thirdly, NEC Section 110.13 addresses the mounting and cooling of electrical equipment. Equipment must be securely mounted to prevent it from falling or shifting, and it must be installed in a manner that allows for adequate ventilation to prevent overheating. This is particularly important for panels and other equipment that generate heat during normal operation. Fourthly, NEC Section 110.14 provides requirements for electrical connections. All connections must be made with approved connectors and terminals, and they must be properly tightened to ensure a reliable and low-resistance connection. Loose or corroded connections can cause overheating, voltage drop, and even arcing, which can lead to fires. Fifthly, NEC Section 210.8 requires ground fault circuit interrupter, or GFCI, protection for receptacles and dwelling units in locations such as bathrooms, kitchens, garages, and outdoors. GFCI protection is designed to protect people from electrical shock by detecting ground faults and quickly interrupting the circuit. Sixthly, NEC Section 210.12 requires arc fault circuit interrupter, or RFSI, protection for branch circuits in dwelling units that supply bedrooms, living rooms, dining rooms, and other similar areas. RFSI protection is designed to detect arcing faults, which can be a common cause of electrical fires, and quickly interrupt the circuit. Seventhly, NEC Section 225.30 limits the number of feeders or branch circuits that can supply a building or structure. In general, a building is only allowed to be supplied by one feeder or branch circuit unless specific conditions are met. This is to prevent overloading the electrical system and creating safety hazards. Eighthly, NEC Section 230.70 requires that the service disconnecting means be located at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. This is to allow firefighters and other emergency personnel to quickly disconnect power to the building in case of a fire or other emergency. Ninthly, NEC Section 310.15 specifies the requirements for conductor ampacity, which is the maximum amount of current that a conductor can safely carry. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature in which it is installed. Conductors must be sized appropriately for the load they will be carrying to prevent overheating and potential fires. Tenthly, NEC Section 408.36 requires that panel boards be protected from physical damage. This can be accomplished by locating the panel board in a protected area or by installing a barrier to prevent accidental contact. Physical damage to a panel board can create safety hazards and disrupt electrical service. Addressing these 10 NEC sections directly contributes to the safety and reliability of electrical installations.